We will continue from the last day's class. Now we will talk about some of the property. We had studied about the structure of DNA. Now we will talk about some of the properties of physical properties of DNA. The first thing which we will be talking about is the melting temperature of DNA. You know, between A and T, there are two hydrogen bonds. And between G and C, there are three hydrogen bonds. Three hydrogen bonds. So one thing is for sure, GC binding is stronger than AT binding because there are three hydrogen bonds, and in AT binding you have two hydrogen bonds. Now we are questioning the stability of the DNA, how stable the DNA is. And it can be measured in two ways. One way, by ways, one of which is the melting temperature. It measures the stability of a DNA duplex or a double-stranded DNA. So we know that nucleic acids, they absorb at a maximum of 260 nanometers in a spectrophotometer. In a spectrophotometer, it absorbs at 260 nanometer UV. It will absorb more of this UV rays. Result is the more absorption, the more concentrated DNA, the less absorption, less concentrated DNA. So if you have the absorbance coming from here to here and the temperature, you will see gradually when you heat a double-stranded DNA, the DNA stands to melt. That is, the double-stranded, it starts to open up. They are opening up. That is known as melting. It is known as melting. And gradually, at a higher temperature, it becomes two single-stranded DNA. Here you have a double-stranded DNA. Melting temperature is the temperature at which 50% of double-stranded DNA is converted to single-stranded DNA. 50% has half of it. That is, this is the 50%. Double-stranded DNA has converted into single. So the more GC content, that means the binding is much more stronger. So you need more temperature. So more GC content DNA, they will have a curve which is something like this. it will shift more towards this side. You will need to give it more temperature to make it single-stranded DNA. Double-stranded DNA has got lower absorbance, and a single-stranded DNA at 260 nanometer will give a higher absorbance. Clear? Yes, no? बोलो, समझ में आया?
Yes, sir.
Okay. The next thing which we to do is hyperchromic shift. Hyperchromic shift means at UV 260 nanometer, light is being passed at UV light. Absorbance of DS DNA is lower than single-stranded DNA. Clear? This is known. So this is high. So this is known as hyperchromic shift. Is it clear so far?
Yes, sir.
There is one more thing left in this chapter, and that is hot values. So, if you heat DNA or add denaturing agents, if you heat DNA or add denaturing agents, what happens is that DNA denatures. It becomes from here to here. And then again, you lower the temperature, it starts to reassociate. So depending upon GC 80 content, dissociation and reassociation, they vary. So if you have a lot of GC rich region, it happens that you need to give it more heat to make it denature, and they will reassociate very fast. The moment you lower the temperature, fatak se de wo log lag jayenge. In the case of 80, it is different. Now, if a sequence has lots of repeats, when there are lots of repetitive sequences like ATGC, ATGC followed by what happens? When you denature, you have a DNA like this, lots of repetitive sequence. They are associated like this. All these regions are repetitive. So it can be that they will, when they reassociate, they can even reassociate like this. Since they are repetitive, they will reassociate much faster. সব সেম আছে তো, একটু খুললো, খুললে একটু নামলো, নামলে আবার জুড়ে গেল এরকম, আবার কিছু কিছু এরকম জুড়ে গেল। So the in repetitive sequence, the reassociation is much more faster. So it is measured by through what analysis. So this is the technique based on the principle of DNA reassociation kinetics. It measures how much repetitive DNA is present in the genome. So C is, what is the initial concentration of DNA? You are measuring the DNA at UV 260, at absorbance 260, UV light 260. So how much DNA do you have? And T is time in seconds. So you multiply it, the concentration of DNA into time. So it has been multiplied like this, concentration into time, and fraction of DNA remaining single stranded. As you know that single stranded DNA will give a much more higher absorbance, 0.5, and when it is reassociated, the absorbance will fall down because of that hyperchromic shift. So E. coli DNA, we have used bovine non-repeated sequences. It's taking a longer time to reassociate back. But E. coli DNA, which is got repetitive sequence, it reassociates very fast. So you can say that E. coli sequence has got lots of repetitive sequences. Clear? समझ में आया?
Yes.
No? Okay. Then this is the end of today's class. ये खत्म हो गया, फिर से हम लोग मिलेंगे on Wednesday. Wednesday 10:30.
Okay, sir.
Okay. Thank you very much.
Okay, sir.
Thank you, sir.
Thank you, sir.